Thanks. Hi, guys. I'm Julie Bonner, and this is Dr. Aman Chandra. And it's quite a mouthful, our title slide here. But we're from Freefall Aerospace, a local Tucson company. I'm going to switch to the next. Thanks. Right here. So Freefall Aerospace is actually a spinoff from the University of Arizona. Here's our team and our amazing office dogs over here. And we're developing new antenna technology. We come from a background of two places. So one, our co-founder, Chris Walker, some of you may know, is still a professor of astronomy here at the U of A. And then Doug Setson, our CEO, was at NASA JPL for almost 30 years. So we have a great team of experts. And this is an image of our inflatable CubeSat antenna when it was being tested at high altitude a few years ago. We're going to talk more about that in a second. Some of the applications that the antenna technology we're working on include ground stations, deployable antennas for small sats, advanced antenna concepts, and space mission design. And next I'm going to hand it over to Aman to talk more about specific mission.
Hi, good morning. My name is Aman Chandra. I'm a recent PhD graduate from the University of Arizona. And I wanted to talk a little bit about the CATSAT mission, which is an active CubeSat mission led by the University of Arizona. And Freefall Aerospace, it's also a great example of the university collaborating with a local company like Freefall, where Freefall's been involved in one of the payload systems that CATSAT is going to demonstrate, which is an inflatable antenna system. This mission is called CATSAT. It's a 6U CubeSat that was picked up by NASA's CLSI CubeSat Launch Initiative program and is due to fly on the Ilana 43 mission on board a Firefly Black Alpha rocket. And it's primarily a technology demonstration mission where we are going to be demonstrating two technologies, an inflatable antenna system and a high frequency antenna known as the Whisper antenna, to do some measurements of the ionosphere. But Freefall has been involved in working on the inflatable antenna system, which you see an image over there. The demonstration is meant to take place at a sun synchronous orbit at about 550 kilometers altitude, and it has a nominal mission lifetime for about 6 months. So here's how CATSAT looks in its fully integrated form. This entire integration work was done at the university's Drake building facility, and it's been a major collaboration between engineering, LPL, Steward, Freefall Aerospace, and Rincon Research. And so the primary payload systems here, all of which have been, except for components that have been sourced outside, but all of the primary payload systems have been designed and developed here at the university. And those include an X-band inflatable antenna system that's about a 1.5U system, and a high frequency VIP antenna system that's a smaller, much smaller package size, an instrumentation module where we have HD cameras, software defined radios and processors, and we also have a metrology camera system where we'll be measuring or attempting to measure the surface of the inflatable when it deploys. Also, I wanted to mention that the inflatable antenna here, how it's going to demonstrate a high gain, high data rate downlink is by potentially downlinking high definition images of Earth in near real time from a CubeSat platform. That's not really been done for small satellites of the CubeSat size from low Earth orbit. So that'll be a big achievement if that happens. Just quickly speaking on Freefall and the technologies that we work on, we are primarily focused on spherical reflectors. Here you see an image of the Arecibo reflector, which was an example of a spherical reflector, and that is one of the key, the key focuses of technology at Freefall, is that we are doing ground and space antenna systems that are spherical reflectors, as opposed to the traditional parabolic concept. And the one implementation of that, as you've seen, is CATSAT, where we have a spherical membrane reflector, which really gives us a lot of advantages as opposed to regular parabolic reflectors. So I'll pass it back to Julie. These are some images showing you the inflatable antenna system, the stowage and bus integration process that we undertook at the clean room at Drake. And these are some images on the left. You see images of the entire CATSAT system undergoing TVAC tests, and in the same clean room in the TVAC chamber at Drake. And on the right, you see some high altitude tests that we did of the same system. I'll pass it back to Julie.
Awesome, thank you. So you can tell we're really excited, and now we're thinking even farther ahead about the future and how our steerable antenna will be amazing for cislunar capabilities. Two really big points on the next version, which would be great for this type of thing, would be not only the steerable antenna, but member rigidization, which is sort of the next version of that. We can see this being made into a sensitive receiver antenna, listening to GPS signals from Earth's orbit. And here's this exciting image with lots of beams, but in the future, the far side of the moon, the South Pole, and all those areas will need to have 24/7 access back down the Earth. And the big thing is that our company moves data, and there's no point of having things happening up there if you can't get the data back down to Earth. So as you can see, free fall spherical steerable antennas tech is crucial to creating a cislunar communications infrastructure. Please feel free to contact us. I've included our LinkedIn QR code. We have news coming up we'll be sharing on there, as well as we're hiring for a few positions. Thank you so much.
Thank you. Are there any questions? If you could wait for a second, we're going to bring down a microphone for you so the people online can hear.
It was my impression, actually, that CATSAT was going to launch on a SpaceX Falcon 9, and now it's on Firefly. Am I correct? Why the change?
I think the change was mostly associated to schedule problems that we had, mainly because of COVID and other factors. But NASA manifested us on a Firefly rocket, so that's going to happen later this year.
And I would just like to give a shout out. You had a rather large student team, and they worked really hard on this, and they overcame a lot of technical issues, which is not unrealistic for technology development for a space mission. So your team did the student team did a great job of bringing that hardware together, assessing problems, and getting the thing delivered, or at least tested for delivery. And it's really a great accomplishment.
Thank you. Thanks.
Any other questions? All right, thank you very much.